All right, hey, I'm live. How's it going? Hope you're having a good day. I'm back on here doing another leak code, and this one looks like a toughie. So, it's called Possible Bipartition, and we're given a set of n people, and we want to split them into two groups of any size. Each person may dislike some other people, and they should not go into the same group. Formally, if dislikes at I is equal to A and B, it means that they're not allowed to put the people A and B in the same group. Return true if and only if it is possible to split everyone in the group this way. Okay, so it reminds me of like assigning seating at a wedding. And you don't want to put people at the same table who don't like each other. So in this example, there are 4 total people. Numbered 1 through 4. 1 dislikes 2, so we can split them up. 1 dislikes 3, so they have to go in the other group. And then 2 dislikes 4, so we can put 4 over here, and we're good. So that's true. Now this would have been harder if they gave it to us in a different order. So if you imagine we got these 2 first, and then this one last, then we might have gone and said, hey, 1 and 3, sure. Let's keep them in the same group. 2 and 4, yeah, sure. Let's keep them in the same group. Oh, 1 and 2, now we have to rejigger the groups. And that is a bad situation to get into. So we see another item that means we have to rebalance, and maybe we have to bump things around. It's a big bad shuffle. So I don't want to go down that path. That's not a good path. It seems like a hard problem, so I'm thinking it must be dynamic. There'll probably be some sort of dynamic solution that involves saying either in your group, you're in this group, or you're in that group. But before we get there, it really looks like a graph problem. So I'm going to take a look at this one. So we got a graph here. And so we can say that 1 hates 2, 2 hates 3, 3 hates 4, 4 hates 5, and 1 also hates 5. So there's another way of writing my graph. It's the same information. I just changed it from an adjacency list to, well, I changed it from whatever you call this. I always forget what this is called, into an adjacency list. So what do we want to know here? How do we deal with this information? So how can we solve this? So if we started with 1 and we say you can't be in the same group as, so we could split it up this way, 1, you can't be in the same group as 2 and 5. Okay. So we could then go to 2 and say you can't be in the same group as 3. And we could go to 5. And 5 likes everybody. So that is complete. So far we're good. We can go to the next unvisited item, 3. And we do know something about 3. 3 can't be in this group, so 3 has to go in this group. Oh, no, sorry, 3 is already in this group. Which means 4 can't go in this group. So we put it down here. And then when we get to this one, we say, okay, 4 dislikes 5, can't be in the same group as O, so this is false. So I solved that as a human. And that felt pretty good. Not sure how to codify it yet. Let's take a look at one of these other examples. Or maybe I could just remove an item from this and use this one again. So here, but now instead of 4 disliking 5, let's say 4 dislikes 6. Sure. So here we build up our adjacency list of dislikes. It's 4, 4 goes to 6, 1 goes to 5. Okay. So just based on that first line there, we know this is one group, this is the second group. And then I kind of want to just follow the chain and say, okay, now go to you. Okay, you're already in a group, we know that, so you just have to go in the other group. Is that okay? Yeah, that's fine. And we could do kind of a depth first traversal. Go to here, say, hey, you can't be in the same as you, so that's fine. Go to there, say, you can't be in the same one as you, so that's fine. And so we've got a true there. Still not quite sure how to codify it, but I feel good about the rules there. Wonder if there's anything I'm missing. What if we made this fail again? We'll do it again. So we'll say, I don't know, 3 doesn't like 1. Okay. So here we say 1 and 2 can't be in the same group. 2 and 3, 3 and 4, 4 and 6, 1 and 5, and 3 and 1. Okay. So, are we going breadth first or depth first? I think we're going breadth first. So we pick a random group for the first item, doesn't matter. And then all of its, every other item in that list goes in the other list. Okay. Now, the trick is we can't just hop to another one of these because we may not know which group it goes to. So we want to hop to one that is connected to one of these. So we'll go here, do another breath first. So we'll say 2 has to go in the opposite one of 3. Okay. This one's complete. Now we go to, well, if we're doing breath first, I would go to 5 first. 5 likes everybody, so we're good. Okay. So now we go to 3. So we go to 3. We say you don't like 4, so you have to go here. And you don't like 1. Oh, that's not going to work. Because 1 is in this group, so I can say false for this one without going any further. So the time complexity, it would take us n to go through and reformat this data structure in a way that is more palatable for me. And that's good. What if I did it as a matrix, though? I'm going to shrink down the numbers. Use another example here. It's a little smaller for this one. Matrix means more space, but it can also be fast. So here I've got a 1, 2, 3, 4. Here I've also got a 1, 2, 3, 4. Put a space there, and we'll initialize everything to 0. Say we don't know anything about it. We don't know if there's a connection or not. Okay. So 1 and 2. 1 and 2, I'll put this as an X. Say they cannot be. Okay, 1 and 3 cannot be. This also means that 2 and 1 cannot be, and 3 and 1 cannot be, because this is cyclic. Okay. 2 and 4 cannot be. So 2 and 4 and 2 and 4 cannot be. Now, how do I know, given this information written like this, that this is in fact valid? Well, I can see here that going across, 1 can be 0 or 4. Okay, that's not super helpful. cannot be 2 or 3. Oh, but I could also cross out themselves. Yes. So 1 and 1 crossed out, 2 and 2 cross out, 3 and 3 cross out, and 4 and 4. Okay, so now I can see that 1 and 4 have to be in the same group. Go through 2. You can see that 2 has to be in a group with 3. Yeah, this doesn't really help me very much. I like the other way better. So let's do the other way again. We convert it to adjacency list and see how we like it. 1 hates 2. 1 hates 3. 2 hates 4. When it comes time to split up, it gets the first group because it's the first item. Both of its items it's linked to get marked in the other group. I feel like there's some better way to say this. Like, what does it mean to say that it's not connected? So here I know 2 and 3, so I know the reverse is that 4 is the only available option. You must be in a group of 4. But you don't have to be in the group of 4. 4 could be in this other group. It just happens that it won't be, but we don't know that yet. So all we can do is say that you are in a group and that you must be in the other group. And then we come down to index 2. Index 2, whatever one it's in, which is this one, cannot have the 4, so the other one gets it. We're still valid. No duplicates is how we tell if it's still valid. And if we do this in a hash table, that'll be O1 lookup, constant time. No problem there. And then when we come and look at 3, there's no children, so we can say that this is valid. So I think this solution is good. Let's try it out. Possible bipartition. I feel like I'm missing something. File new. I keep forgetting. I know this shortcut. Control Shift Insert. Control Alt Insert. Possible bipartition. Test. All right. So there we go. So what we're going to do is we're going to loop through the dislikes. I don't care about the index. I could fold. My initial value is going to be a hash map of a mutable list of integers. Yeah, sure. That'll be in my initial value. Yeah. Map. Why don't you like me? 2 type arguments. Oh, I need to give it the initial value. Okay. Nope, that's not true. I don't need to keep that. I need to tell you that. Just say mutable map. Oh, it's okay. Dang it. It's because mutable list is an interface. What I need is like an array list or a list. I do that. What does fold look like? Takes an initial value of type R. Okay. That seems good to me. What am I doing wrong? Let's baby step this thing. Okay. Two type arguments are expected for the value. I just assumed it knew. Okay. There we go. Now we're going to fold, and the items we get for the arguments are something and something. I already forget the order of them. It's T first. The accumulator first, and then the T for the key. Okay. I need to close some of this garbage. Okay. So accumulator and key, sure. Accumulator is our map. So accumulator at, can I say set or get or default? Get or default for the value key. And the default is going to be a list, mutable list of integers. Oh, I guess I do have these backwards. Oh, it's an array. Oh, right. Key at 0. Mutable list of. Gross. I'm just going to initialize so I don't have to worry about this. Let's see, for something like I and N or something. Zero, 1 dot dot N. Okay. This, no. Let's see our map. Call it graph. Graph at I equals mutable list of. Alright, with nothing in it. And then down here, we can do a plain old for each. Okay. And then we don't have an accumulator, we just have it. So we say graph dot push graph at it dot add mutable list. There we go. It's all come together now. We're going to add it dot at 1. You are it at 0. I don't know if we can have duplicates. It'll be there. Dislikes at I at 0 was less than I at 1. Hey, what's up, Slade? Thank you. That's very nice. I feel like my best self today. We're gonna nail this one. Dislikes at I at 0 is less than dislikes at I at 1. I'm taking that to mean that they will never be equal. It was just like a mathematical way of saying that we won't have duplicates. I'm choosing to believe this. Okay. Now what? Now we've initialized our graph. We have gone through and created our, I'm going to call this adjacency list. Adjacency lists, plural. Now what? We have group 1 and a group 2. What kind of data structure is appropriate here? I want it to have fast lookups. I want to know very quickly if an element is in it, so a map makes sense again. Hash map. And what are our keys? Well, it's an int. You know, it doesn't have to be a hash map because I don't have a value. It can just be a hash set. Okay. Group 2, same thing. All right. It's down here, so I can basically just say adjacency lists at which one should I start with? So I'm just say keys equals I want to get the first one that has a value. That's pretty annoying since I've done this. I've pre-initialized it. That does save me a lot of null checking. So yeah, I mean, I'm just gonna do this. So we'll say var current equals adjacency lists dot first. There's no first. Is there an I don't want to. Is there really not a first? They call it find. Ooh. I want to get the first item that has something in its list. Any or all? Nope. I don't understand why they have to have an all or an any, which I kind of consider kind of more advanced functions. And there's not a first. Is there a last? Wow. Okay, well, let's ask Google. Map first. I need to map a list and retrieve the first non-null element. That's like what I want to do. Kotlin has evaluated sequences that correspond to Java 8 streams. Instead of invoking stream, just say as sequence dot map dot first or null. What? First or null. I guess hash map doesn't count as a sequence. Or default, first or null. Man, that is definitely doing more work than I wanted to. I guess I'm just gonna not do that. So, old-fashioned way. For k in adjacency list dot keys, if adjacency lists at k dot any, then we can break. Current equals null. It'll work. Current equals that. What are you crapping about? Oh, because I didn't set the type. Mutable list dot empty. No, that doesn't do what I want. Man, I don't like any of this. Fine. List of. Alright, fine. But that's not actually what I'm getting. Actually, what I'm getting is going to be... yeah, it is a mutable list of integers. Okay, so we come down here. I'm telling you, it's not null. So we have our current value. So if current dot is empty, this should never happen. Then that should never happen. I'm not going to worry about that. I don't even know what answer return is not defined. Okay, so what do we do? You know, really, I don't want the current. I want the current to be the key. So let's just keep the key. All right. Almost there. Doing a lot of looping here. Like we know that the input size is pretty small. I think they said 2,000. So that should be okay. This doesn't technically affect our runtime, but it's not going to go very fast. So we find our first item with an element. So we can say group1.add current. There we go. So now what we can do is, hey, let me fix chat real quick. Dang it. I did this earlier. Sometimes you got to do it a few times. All right. Everyone's got to know that I'm the best. Thanks again, Slade. All right. Group 1 add. So now what? Very important. I'm going to show this to my mom later, so just got to see it. What are we doing now? So now we add, I'm going to turning this into a loop, but basically we add the current item, and then group 2, we sort of add range. There's add all, which is going to be adjacency lists at current. So I'm skipping a couple steps here. Type mismatch. It'll be there. Nulls. Okay, and then we want to set current equal to... Oh, geez. Are we going to get recursive here? Or do we want to keep a queue? What's easier? Keeping a queue, I guess. It's linked list. It's going to be queue of integers. So we will add. Is there an add all? Yes. We will add all our items from here to our queue. And then while queue has anything left in it, there's anything left in queue, we can say current equals queue dot first. There we go. We do have to check if already visited. I'll do that in a minute. Just don't want to forget it. So I'm prone to forgetting that check. All right. Now what? I basically do these steps, except that the group that I'm going to is going to change. So we'll keep like I don't know, a variable next group equals 2. And we'll flop this variable back between 2 and 1, It's gotten long. It's not really a hard problem, but I'm doing a lot of stuff for it. A lot of moving parts. I'm not testing in between, so this is going to be horrible. Oh well, horrible is my specialty. Alright, current equals the first item in the queue, and what do we do with that? Maybe I don't want to automatically add them here. Oh, I think it's alright. So current equals queued up first. And then what we can do is say adjacency lists dot not dot at current will not be null. This is going to give us a list of all the items that cannot be in our group. We know that the group that we're looking at currently is 2, so really I should say the next group is 1. Right, so something like this is going to get ugly. If next group equals 1, else val group equals, if next group equals 1, then it's group 1, else it's group 2. I could have done a when there. It's a little nicer. When next group is 1 in group 1. 2, it's group 2. A little nicer. One must be exhaustive, which means I can do else instead. Alright, let's do that all in one line because I'm going to regret it. It's not a very good reason. Whatever. Okay, so we figure out which group we're going to add to. So group.add all. And do we want to check them first? I think so. Oh gosh, this is so awkward. Well, other group. Oh man, that is grody. Group and other group. Wow. This is embarrassing. I'm sorry you have to see this slide. Feeling uninspired with that name. So for every item in this list, we are going to add it if it's not already in the group, and it's not in the other group. I guess I don't really care too much about duplicates. It's kind of a different thing. We'll deal with that in a sec. Alright, so if the other group contains my item and I'm trying to add it to the current group, then we got a problem. So that's return false. That's a hard false. In all other cases, we return true. Okay. Finally, if the item doesn't already contain the list. This just keeps the list small. It's probably not necessary, but whatever. Okay. So I think we're almost done here. Now we do have to check if something has been visited or not. There's a couple different ways to do that. And I'm thinking some allocating so much memory anyway. Why not allocate more memory? Call this visited. Sure. I've already kind of given up on life here. Oh, and we have to also next group. We have to increment next group. So if visited dot contains my element. Where did I get I from? Oh, okay. If I've already visited this, then we can just continue. We'll go back around. We'll get the next item. Okay. Else, well, I don't need else. Visited dot add current. Okay, then the last thing we have to do is toggle this group, which we can do basically. Oh gosh, when do we do it? Oh my gosh, when do we do it? Oh my gosh, that stinks. It's not really very easy to tell. So I know my X group is 2 for all of these people. Or it's 1 for all of these people. Answer that later. So we go through, loop through all my children, everything in my list. Is it okay to toggle my group then? Group equals next group plus 1 mod 2. So if group is 1, I'm going to add a 1. Which will make it 2, which will make it 0, which is not what I want. So my next group is 1. I think I'm just going to do this crappy one again. When next group. It's not the slickest way to do it, but it's the most readable. When it's 1, I want 2, else I want 1. Why are you yelling at me? Oh, arrow. Okay, so now we've done this. I'm going to be a jerk and do this just because it's getting so noisy in here. Which really should be a sign that I should have broken this out into smaller functions, which would have been much easier to test to. But I'm not going to do that. So I'm lazy. I like to do things the hard way. It takes longer. No. Fun. Does it work? I think 4 was the first example they gave us. Array of list of. That's surprisingly annoying. List of a list of. To array. List of, what are we going to do? Array of 1 to 2. Let's see, what was that first example they gave us? 1 to 2, 1 to 3, 2 to 3, 1 to 3, and 2 to 3. Okay, so we've got a list of those, and we wanted to say to array, to typed array. Okay. Call this dislikes. And I gave you, oh my gosh, int array of, very important. And I'll probably get syntax errors and all sorts of good stuff. So assert equals, I expected in this case, should be true. Survey says it's not going to be true. It's going to error. Yeah, see, I knew it. Oh, hey, it didn't error. So it gave the value false. Okay. So I kind of feel like I messed up something with the groups, most likely, because that just, there's no way that works. It's just too fishy. Too fishy. All right. Oh, I will. Thank you very much. It's the encouragement. This is totally going to work any minute now. What up, Will? We got a pretty easy one. I'm working with your friend adjacency lists here. So I'll show you the problem. It's kind of cool. So we have a list of people that don't like each other. It's kind of like assigning chairs at a wedding. And you need to split up these two groups so that nobody's in the group with someone they don't like. So in this example, 1 doesn't like 2, 1 doesn't like 3, 2 doesn't like 4. So we can split them into groups of 1 and 4 and 2 and 3. And so my solution was basically, I'll show you with this example. I'll show you this one. It's a little longer. It's really simple, but somehow I'm doing a lot of typing. Is basically I create adjacency lists and convert it so 1 doesn't like 2, 2 doesn't like 3, 3 doesn't like 4, 4 doesn't like 5, and 1 also doesn't like 5. So now I go through and I loop and I say, hey, you get your own group because you're first. And everyone that you don't like goes in the other group. And then I keep a queue and I initialize it with these two to say that I need to visit them. And I'm basically just doing a BFS at this point. So this one's been visited. So we can cross that one off the list. Now we pluck the first item off the queue, which is the 2. So we come here, and so now we have to look up which one 2 is in. The 2 is in this group, so we add all of its children, or all the items in its list. Yeah, so linked list implements queue. Check this out, that's why I did it. Linked list. Wait, sorry. List. No, what am I doing? Did I do a linked list? Where did I do this? Oh yeah, so I created a linked list. So if you look, linked list implements, they call it DQ, but if you look at DQ, it's basically a queue. It extends queue. So nice little trick there in Java. Yeah, so then I loop through this one. I say, okay, 2, you have to put the 3 in this group, whatever the other is. And I have to do some checks there to make sure that's okay. Then I in-queue 3. Get the next item off the queue, which is 5. 5 doesn't have any items, so I get the next item. Ooh. Crap. So I messed up my BFS because I don't look for like islands. So Like right now, 3 is the only item in my list because 5 didn't have any items. So I need to make sure never to skip any. Well, that's pretty yucky. Alright, well, think about that in a minute. So a lot to do here. Check for islands. And basically, if we see any islands, then we start over the process, the whole thing. So we'll wrap this in a function, and we'll just do the whole thing. We'll run through it again, and we know it's disconnected, so it shouldn't take that long. Yeah, good call. Good call. Oh yeah, so I didn't finish running through the example here. Sorry. So now we look at 3. It's got 1 item, so we can mark 3 as visited. In queue, it's 4. 3. Find out its group is here, so put the 4 over here. And mark that. And then finally, we look at 4, which has a 5. Ooh, so 4 doesn't like 5, but I can't put 5 in this group because it already exists in this group. So this is false. And if we scroll up, hopefully this is false. Yes, okay, cool. But to program it, it's just been kind of finicky, so I'm not doing it in a very smart way. Like I'm doing this weird group toggle thing, which I just shouldn't do. I shouldn't try to toggle the group like this. I should look it up. I mean, I think I probably could do it that way, but it just doesn't feel good. I'm not going to try and predict the next group based on whatever. And so my current group is going to be equal to wherever I am, whatever group I'm in. So if group 1 contains me, current, then the group I'm adding to is group 2. Oh man, there's no ternary. We talked about this. If group 1 contains the item, then we return group 2, else we return group 1. Reformat everything. All right. And I'm not going to set it like this. I'm going to do it old school styley. Oh, dang it. Which means this has to be a var. Fine. Man, I messed everything up. And the reason I want it to be a var is because I'm going to add other stuff in here. So other group. This just feels so wrong. This is very inelegant, which is a bad sign. So other group will equal group 1, other group will equal group 2. And these need to be mutable lists. Which feels even wronger. Because now I'm creating empty lists for no reason, and then the next thing I do is get rid of them. So we'll come back and optimize that. I don't want to get hung up on that. Why are you squeaking at me? Group equals mutable list of integers. Other group is a mutable list of integers. Did I get the types right? Oh, it's a hash set. Duh. There we go. A hash set of ints. What is the problem here? Whatever, I'm just going to ignore it. What could go wrong? So let's start back over. If we visit the item before, we don't need to do it again. Otherwise, we'll add the item to our visited list. We'll figure out the group that we should be setting items to and the group we should be checking against. I don't need to do that then. There we go. That's what the problem was. All right, so we got rid of some nesting, which I like. All right, everything's happy. So, for I and adjacency lists, if the other group contains my item, meaning I'm trying to add this thing to my group and it's already in the other group, can't exist in both, so that's our failure condition. It's our only failure condition. And then here I've got a nice little thing where it's, if we've already added this to the group, don't add it again, just so we don't end up with duplicates and have a longer list than we need. I'll go ahead and write a failing test for islands so I can get rid of the to-do. By islands, I just mean detached items. And hopefully that will be enough to remind me before I submit. Make sure that fails. All right, good. So I don't think I actually changed the functionality here, so it should still get the wrong answer. All right. Yay. So now I was going to do just a bit of debugging to see where we at. I gotta do something about that yellow. Adjacency list, my size is 4 because my n was 4. Yep. This lake's got initialized, that's fine. In a BFS, after visited 1, the second layer you should visit 2 and 5, right? But when you went through the example, you went in the order of 1, 2, 3, 4, 5. I wonder if I did it wrong when I traced through it. Let's see here. So I should have said 1 gets 2, 2 gets 3, 3 gets 4, 4 gets 5, and 1 also gets 5. And then what I should have done is pre-initialized my queue to 1. And then I should have come in here, gotten rid of the 1, and added the 2 and the 5. Then I should have gone to 2, added the 3, remove that. And the next one I should have gone to should have been 5, which doesn't have anything. And then the next one was 3. So I'm going to remove that from the queue. 3 would have added 4. And 4 would have added 5, which was the dead end again. So, did I do it right that time? Yeah, I did. I should have gone 1, 2, 5. 1 was added to group 1. Yeah, so to make that clear, that's a good point. I should make this part better. So down here, what I should have just done is just enqueued my first item. So I just should have said queue.add, add first, whatever, current, which, I don't know, I should have just called it first. Oh, hey, yeah, sorry, man. I actually thought you were my buddy, Will Madison, which does a lot of streams, so I kind of took it for granted. Sorry. Your question is, should you still listen and watch all these even though it's above your head? Honestly, I think if you're enjoying it, then yeah, stick with it. And if you feel like you get something out of it, I know that's not a great answer, but sometimes when I go to like a conference or talk or something, I'll go to talks I know nothing about, just because when you know nothing about a subject, you get like a lot more value for your time, and sometimes. But if it's driving you nuts and it's irritating you, and you aren't enjoying yourself, then don't do it. Don't do anything that's going to discourage you, I feel like. So the stuff that I do just tends to be stuff that interests me, and the stuff we talk about on the show tends to be stuff that kind of interests us at the time. And so, it's really up to you. Of course, I want you to stick around. you know, I hope that it starts making more sense. But you know, ultimately, you got to do what's right for you. And there's a lot of really great shows out there. And so, you know, I definitely don't want you to listen to us and not get something out of it. So, yeah. So I don't know. You have to let me know what you think, though. You know, I have other hobbies and stuff where I listen to things, and I think sometimes I stick with it and get something out of it, and sometimes I quit. So I don't know the right answer. Well, good. Glad to hear it. It's fun, man. Oh, you know what I should say too. So the stuff that I'm doing even today, like I've done live streaming these coding challenges for like 60 plus days in a row now, and I'm still struggling. Like I've been doing this problem. It's a medium problem for an hour now. So even after years and years of doing this, I've been programming professionally for like 19 years now, and solving these problems literally every single day. It's still hard. It's still frustrating. There's a quote I used to hear about. There's a bicyclist that said, "It never gets easier. You just go faster." So it's always going to be hard. There's going to be times that are frustrating, but there's going to be times that it feels so good, and you get to make really cool things. And when it works, just there's no feeling like it in the world, I think. Oh, cool, man. Glad you like it. I did take a couple days off streaming. I've had the webcam, so I just kind of solved them. It's definitely harder to kind of program and talk through at the same time, which is, I think it's kind of good practice to do too. So what was I doing? So Q dot, we're going to add the first item, and I'm not going to do this add all stuff. And I will do this one though. I will add you to the current. That way I can always assume that whenever I get the item down here that it's already been added to a collection. Yeah, so this is also a really tricky problem. You know, if like there's so many ways to go wrong with this problem. Like if you're not used to doing program challenges like this, like, you know, you might have kind of been tempted at first to like say, let's say we'll look at the simple example. It's tempting to say, hey, 1 goes in group 1, 2 goes in group 2. Next one. Okay, well, I've already got 1 in group 1, so let's add this to 3. And then down here, 2, we've already got that, so add it to 4. And that'll work simple. Hype Zack Snyder. I don't know Zack Snyder. Zack Snyder. Dark Side. I don't know what that is. Well, I mean, I know who Darkseid is, of course. I'll tell you who Darkseid is. It's my new wallpaper. Kind of looks a little bit like Thanos. I don't know which one first. But, oh my. This is bigger than 4K. Thank you for the wallpaper inspiration. Very important. Seems like there ought to be an easier way to set a wallpaper. Back in the day, I used to just be able to do it from the browser. All right, there we go. Dark Side. All right, totally lost now. Yeah, so kind of talking about like doing this the normal way, it seems like it's going to work really well. Oh, nice. Okay. Yeah, all right, Dark Side did come first. Okay. I had a cool Dark Side cup. I wonder if I can look it up. When I was a kid, cup, mug. Yes, this was it. So I had this cup when I was a kid that had Dark Side, and you could like put the cup in there. And man, I used to play with this thing all the time. This is like a toy that I really enjoyed. But looking at it now, it doesn't look very exciting. But it was super cool. Oh god, did it say the year on there? 1988. Awesome. Long time ago. Yeah, it was super cool, man. I kept the cup. I mean, for a long time, I had that thing kicking around forever. Like maybe until a couple years ago when I got married. Then suddenly some things disappeared. Yeah, so if you do it this way, it'll work for this problem. But when things get gross, like if you just reorganize this problem, it's easy to see what the problem is when you do things like that. So here you come in, you say, okay, 1 doesn't like 3, fine. 2 doesn't like 4. Okay, which one do you put the 2 and the 4 in? They're disconnected, so you have to decide. So here maybe I'll say, okay, I'll put 2 and 4 here. And when you get to the next one, you see 1 doesn't like 2. Oh, this is invalid. So we have to take the 2 out of here. And what was the reason I put the 2 in here? Was it was the 4, so I could swap the 2 and the 4. Okay, and then I can add well, then I'm already done. So you could do that, but you can imagine, like, as you get further and further down the line, like if you know, this item didn't come into like way down here, then you'd have to do something to keep track of which items were the reasons you put things, and it can build on each other, and you just end up in this nasty dependency tree. Which, now that I think about it, would have been a different way to solve this problem. You could treat it like a dependency tree. Maybe. I don't know if that would work. After 1, you check 2 and 4. So you do 1, 3, and then 2 and 4. Yeah, I mean, I guess you could defer that decision to say, okay, we're going to hang on to this one, do it at the end or something. I don't know. I just wasn't really sure how to get around that problem without, like, things getting messy. I was imagining having to rebalance and then rebalance and rebalance. Alright. Geez, I don't even know what I was doing. So add the first item to the queue. Group 1, we add the first item to group 1. And from there on, we're going to assume that our group has whatever item we're currently looking at. We're not going to add all. We're going to let that happen down here. So while there's still anything left on my queue, and I'll spell it correctly. Okay. We'll get the first item out of the queue. And you know, even this, like, I think I'm going to call this val. And up here, I'm going to call this first, just to be clear about the intent here. So we're going to add the first item, and we're going to add it to the group. Okay, so now down here, we get the first item out of the queue. I know, I haven't seen that. And you know what? I should not be getting the first like this. I should be basically removing first, not just getting it. Yeah, great. I don't know. I've seen AI do some dumb stuff, so I'm not too worried yet. I can't get my phone to do anything like Siri. Siri hates me. So I'm not too worried about the apocalypse just yet. Not yet. Give it 20 years. So remove the first item. And if visited contains it, then we'll continue. Otherwise, we're going to add it to visited and continue. Now, this is the worst. This is just so gross. I think I'm not going to do that. That just feels too bad. I'm just going to set it to null, which means that this has to be a nullable type, which is what I was trying to avoid. Alright, fine. So if group 1 contains our item, then we know that we'll call this next group. And instead of other, we'll call it, I don't know, off group. I seriously don't know what to call that. Okay, so the next group will be the group that we're adding our items into, and the off group will be the one that we're not. So we're gonna loop through all the items all the people we dislike. So maybe I should call this disliked. So if the off group contains the one that we dislike, and up here we can see that the off group equals I don't even know how to read this. If the group 1 contains our item, then our off group, maybe I should call it good group and bad group. Ooh, current group. Current group and next group, that's better. So we can see if group 1 is the current group, then the current group is group 1. That makes sense to me. Otherwise, current group is group 2. Okay. Yeah, sure. AI parts are on the 30-minute mark. Yeah, definitely. What does WUW mean? Is that like metal? So for each disliked item in the adjacency list, if the current group contains the item I disliked, then false. That makes sense. That means my current group contains something that I dislike. That's good. Now, if the next group contains the disliked item, then we just don't add it to the next group because it's already there. That's good. So we've handled everything but islands. I still don't think I've changed any logic. So this test, even though I've cleaned a few things up, oh my gosh, apparently I did fix the bug. All right, so hey, that worked. Let's try, we'll call this one simple test. And I have a feeling that that's a good solution. I think it's sound. Oh, smug face, that's cool. I haven't seen that one before. All right. I don't know, we call this one maybe simple true, simple false, something like that. So we got a 1, 2, a 1, 3, and a 2, 3. That's what I already did. 1, 2, 1, 3, 2, 3. 1, 2, 1, 3, 2, 3. Oh, wait, what? I think I done goofed up my test. So this one should have been 1, 2, 1, 3, 2, 4, and it should have been true. So, yay, I got the test to pass, but it shouldn't have passed. It was right the first time. Ah, jeez. I need to fix the name, and somehow it's still true. So, okay. So 1, 2, 1, 3, 2, 4 equals true. Seems like it's always equaling true right now. And in this case, what? Simple true. This one should have been simple false. Because 1, 2, 1, 3, 2, 3. 2 and 3 cannot be in the same group because they're both, oh, so both in the right hand column. That's interesting. Alright, so this should be incorrect. Okay, cool. So still got a bug. It's always returning true. I kind of want to pay attention down here and debug this sucker. Alright, so for every item, if we look at our group 1, hey, somehow group 1 and group 2 are both empty right now. That shouldn't have happened. Oh, never mind. I didn't set the breakpoint where I thought. Phew. Okay. So here we're going to find our first item. So first one is 1. Okay. It's the first item that has a list. And then what? Then we create our queue. We add our first item. And then we add our first group. So now if we come down here, we should see that group 1 has 1. I think I figured out how to fix the islands too. Come back to that in a minute. While queue has anything in it, so yes, we're going to get the current item off the list. Now our queue should be empty. It is, but that's okay. We're going to fill it up. If visited contains the item, nope, good. Now visited contains the item, so if we see that again, we're not going to try and recalculate it and potentially mess up our result. Okay, the current group. Definitely curious to see what happens here. So our current group, group 1 does contain our item. So that means our next group equals 2. Yep. And our current group equals 1. Yep. So for all the ones we've disliked in our adjacency list at 1, which should equal, has a key of 1 and a value of values of 2 and 3. So that's good. Okay, and 3 doesn't dislike anybody, 4 doesn't dislike anybody. Okay, so we're going to loop through and we're going to queue up. Oh, I never add to my queue. So that's a problem. As we go through here, assuming we don't like it, we need to add this item to our queue. Add last. Disliked. So we'll add this item onto our queue. So now I suspect this test is going to work. Smug face. All right, cool. So that's good. So now I mentioned those islands. Let's construct a problem to, or an example to demonstrate the problem. And so we'll take this and we'll add an item that is totally disconnected. So we'll say 9 doesn't like 10. And I don't actually know how to construct this. I don't know. 8 doesn't like 9. And also, oh, you know what? Here's the easier way to do it. 9 doesn't like 1. 9 doesn't like 2. So that excludes it from either group. But because it's detached from the rest, my algorithm is going to say, hey, check 2 and 3, then check 2, then check 3, and then we're done. And it's never going to check 9 and see that it's invalid. So this, we'll say 2, 4. So this will return true, and it should return false. There we go. Oh, wait, no pointer exception. What happened there? Oh, because I didn't set this up to 9. Not that one, this one. All right, good. So we expected false, we got true because of that problem. So what we can do here is, instead of this nasty bit where I go through and try to find the first item, what we can do is what? For I don't know. What's a variable we haven't used yet? Is I safe? Yeah, I looks safe. You know, if you have to scroll down to see if you used a variable for your function, it's too long. I should not be doing this. This is not good practice. for, let's not do I, for I in 1 dot dot in. It's basically what we did for the initialization. We're going to go through and do all this work, which means some of these things our queue needs to come out. Oh yeah, this is gross. This is grosser than I thought. Alright, all this garbage needs to come over one. Checking for the islands now. So, we've got our queue. If queue dot size is empty, then we can add the item to our queue and the first group. And then let's keep a variable called initialized or something. False. And we only do this if initialized is equal to false and the queue size. Well, I don't think I care about the queue size. If initialized is false, then we do this and we set initialized equal true. I like that a little bit better than what we were doing. So basically what we'll do now is we'll start at 1 and we'll try it. If it has an adjacency list, then we'll go on and business as usual. If it doesn't, we'll try 2, we'll try 3, and so on and so forth. Does that work? We've got this visited data structure. That's going to know if we've seen something already. Oh. Alright, so if it's not initialized. Alright, let's try the tests. Does the simple case still work? Yep. Does the simple failure still work? Yep. What about our islands? No. Oh. How did I mess up the islands? I really thought this was it. Oh, I don't do anything else with I. I guess I could just always queue up the item. Here. But I only want to add it to the group the first time. Let's try that. I believe that is the case. All right. There we go. We handled the islands. Smug face. Okay. This is not a pretty solution, but I'm okay with it. Let's try running it over here. We got a couple util. What did I do with util? Alright, let's see if this works. Okay. Try submitting. Wrong answer. Ah. Brutal. Okay, the input was 10. Let's see how many tests we actually made it through. We made it through 40 tests before we failed. Okay. So here is our test. Data. Ooh, I don't want to type all that. This is going to be 10, and they said they expected true. Test failure. right. Trying to think of the laziest way to do this. Like if I replaced all the open brackets in the selection. Okay, only in... I should have just typed it. Selection only. Replace that with int array of boom. Okay. And that one should have just been array of. Oops. Oh no, list of. So list of int array of brackets with parentheses, and the comma's already there. Doing it in the selection. No, we're not doing it in the selection. Definitely only in the selection. Okay, list of blah blah. Alright, have Kotlin do the work. The compiler, formatter. And we got the wrong answer. We knew that was coming. So what did I say false? Oh, I got a whining dog. He says dinner time. What now? So the only time we ever return false is when the current group has an item that we don't like. Our group has an item that we don't like. So let's debug it and see when that hits. Maybe that'll give us a clue. Huh. So that's interesting. I didn't expect that. Our current group only has one item in it so far, and the item is 5. So, what does that mean? Current group only has 5, and we're looking to see if there's a 5. What's in group 2? So this happened right at the beginning. So even though it looked like a longer list, the problem was evident almost immediately. Let's double check that. Is that really the case? So group 1, okay, has size 6. Group 1 has 1, 6, 7, 8, 9. Okay, so it didn't happen right at the beginning. 1, 6, 7, 8, 9, and 10. 1, 6, 7, 8, 9, and 10. And group 2 only has 1? That doesn't seem right. Group 2 only has 5? So what the heck happened in here? Okay, so the way I'm doing the algorithm now, it's going to start at n and basically loop through until it starts. So even though we see a 5 first, it's not the first item we see. It's going to start with 1. And the list it's going to construct is going to look, or the adjacency list it's going to construct. And by the way, if you're not familiar, adjacency list is just a common format for storing graphs. So 1 dislikes 5. So what we did then is we said, hey, auto formatting, group 1 gets 1, group 2 gets 5. All right. Then the next item in 1, there wasn't any. So then the queue went through and said, okay, well, let's check out 5. You know what? Let me build this out first. So 5 hates 9, 5 hates 10, and 6, and 7, and 1 hates 5, and 4 hates, everybody hates 5, and 2 hates 5, and 5 hates 8, and 3 hates 5. Okay, so the algorithm is going to start with the 1. And so let's draw out our queue. It's going to start with 1. We're going to take that item out of there. We're going to add the 5. We'll set up our groups like so. Group 1 has 1. Group 2 has 5. These colors drive me nuts. Now we're going to go look at the 5. So 5's got a bunch. 5 is already in group 2. No need to add it. So we should add all these other items one at a time to group 1. And I think we've seen that happen. 9. And this will also get added to the queue here. So I'll just copy and paste here. So we've removed the 5 and we've added all these. So here's the part where the problem happens. So at this point, we had 6 items in group 1 and 1 item in group 2, which seems really fishy. And this was successful. Or was it? Man, I want to see that keynote. Gotta solve this problem. So I can see the keynote. So where did this fall apart? So what should have happened is we should have marked this one as next. Only put 5 into the queue, not in the group when I visit 1. Okay, let's take a look at that. So down here, to make it more like a natural BFS instead of my weirdo stuff, first we add it to the queue. And what we're saying is we shouldn't have added... No, we added the 1. We added the 1 here. You're saying you should only put 5 into the queue. Oh, I see. I think I understand what you're saying. I should put its children into the queue instead of it. Children's not the right word for it. Yeah, because why would I do that? Would I only put the 5, or would I would put all the items in the list in the queue? Is that right? It feels weird to add multiple to the queue to get started. I don't think I've done that before. What would that mean? Let me try running it and see what that looks like. You put all the adjacency lists into the queue. But then don't I still have to look at... Do I still have to look at it? You're right. I mean, it is weird to like re-add it here. All right, yeah, let's try it. It's easy. Easy to try. So here, group 1, we add the first item. That's still correct. And what we want to do is, instead of adding the first item, we just add all. its adjacency lists at I. That's what you're saying, right? Type inference failed. Nuh-uh. Alright, let's try the tests. Okay. So I didn't get what I expected here. I don't know, I'm not quite seeing that because I'm afraid I'm not looking at the one. So where was this guy? So we add the first. Try stepping through. So here we add, the current is 1, expected that. Visited doesn't contain it. We add visited, you pop node 1 from the queue, add it to the current group if it doesn't exist. If it does exist, then return false. Then add all adjacent lists into the queue. Then swap current next group. Then next round. Yeah, that's what I was kind of thinking about with the rounds initially. And I wish I hadn't gone away from it because it's gotten weird getting away from it. I thought it would be easier, but it really didn't end up being easier. So yeah, I see what you're saying. All right, give me like, we'll say 5 minutes to see if I can figure out what went wrong here, because I think this is also valid. I just think I missed corner case. I hope. So we add 1 to the current list, so we shouldn't see it again. Next group is a hash set. Current group is a hash set. If the group 1 contains the current, and it should, then we set our next group to group 2. Okay, and our current group to group 1. Okay, that looks good. Don't need to see that anymore. Now we're looking at its disliked list, and it only had 1 item that it disliked, I believe. So adjacent list at index 1 has just 1 item, which is the 5. So group 2 should get the 5. Next group dot add. So now if I look at group 2, we should see that it now has a 5 in it. So that's good. All right. So now we come in through here again. Now we're looking, the current should be, wait, what? Why am I looking at this again? Okay, that was just the debugger being weird. All right, so now when we come back through, our queue is not empty. So we get the 5 next, and 5 is the one that had, if we look at it, 1, 2, 3, 4, 5 people that hate him, or that he hates rather. All right, we haven't visited it, so we mark it as visited. Okay, so next group is group 1. Okay, current group is group 2. Yep, that's my group. So I'm the 5. For my dislike list now, I got a bunch of them. So we're adding the 9. We're adding the 10. The 6. The 7. The 8. Is there any others? Lost count. Hash map at 5. Is 8 the last one? Yeah, 8 is the last one. Okay. And what's in our queue? Alright, what is in our queue? Our queue has 9, 10, 6, 7, and then it's going to be an 8 next. Okay. Alright, now we come back around. This is where I think things go wrong. Current equals should remove the next first one, which is going to be a 9. Okay. It's not been visited. And if we look at our groups, just to sanity check here. 1, 6, 7, 8, 9, and 10 are all in one group. Yep, and 5 should be in the next. So everything looks good so far. Where's group 2? Just to double check it. Size is 1, and the value is 5. Okay. Blah, blah, blah. Next group. Group 1 contains current 9, so it should. Yep. Now, for who does 9 dislike? 9 doesn't dislike anybody. So we just come up here and we go to whatever, I think it was a 10. Yep, 10. Does 10 dislike anybody? No, so same thing should happen again. And the 6, and the 7, and the 8. All of these should go back around. Then we should come to the 2. Okay. Okay. That's a problem. So how do I know where to put the 2? So we'll loop through all of these. Oh, geez. Yeah, this is tough. So when I get the 2, right now I'm putting it in the wrong one, which ends up... Shoot. That's a logical problem with my algorithm. That's not a simple error. How do I know where to put this? And 2, 3, and 4 all have the same problem. Your adjacency list of 5 is missing 2. So you're saying I should like basically make it 2 ways? So because I know the 2 doesn't like the 5, I should put, yeah. My example is not valid. Yeah, this is acyclic. No, that's not the way of saying it. This is a non-directed graph. Yeah, you're right. Yeah, so here, when I add it, good call, good call, good call. So when I construct the adjacency lists, blah, blah, here, I need to do it both ways. 1 and 0. Okay, and so that makes this list, it's going to change how this looks. So now 5 will also contain the 2 and the 3 and the 4. Yeah, that's it. Yep, good call, good call. Whew. You know, we even talked about that early on. I just kind of forgot about it. Island, so all the tests pass, including the last one. Oh, man. All right, Adigo Lee, you get the credit for this one. Where is it? Good call. Go. Make sure I spell it right. I'm sure I said it wrong. Sorry about that. Please feel free to correct me. Thanks, everybody. This is non-directed. And I couldn't remember the word for it. I kept thinking like acyclic, but that wasn't what I was looking for. So this is totally it. Oops, I got rid of the imports. This is 100% winning solution. And now I can eat dinner. Yes. It's all 8:15 my time. Oh, I'm ready for dinner. What? Oh, I tabbed too much. The screen went weird. I don't know what happened there. There we go. Try that again. Yeah, great job, Adigoli. You are immortalized in the solution forever. Hey, look at that. Wow, I didn't expect that. And I definitely created more data structures than were necessary, so it was definitely doing more work. We could spend, you know, another half hour on this and really tighten it up, but I don't think it's worth doing it. They did a DFS. I don't know that it matters whether you do BFS or DFS here. I tend to prefer BFS, but not a big deal. And they use colors. Like if you look at like a traditional BFS, DFS, a lot of times they will mark things as colors to represent visited or not. So cool. All right. Not really seeing them doing anything different. They could convert to an undirected graph, just like you called it, and then they initialize. Yeah, so they're doing things a little bit slicker. Lots of nulls, less data structures. So yeah, colors are 1 and 2, groups 1 and 2, basically. Same kind of thing. So so they're literally using color to talk about group 1 or 2, and it's not for marking it as visited. Whoa. Color times -1. Oh, that's how they're marking it as done or not, whether it's negative. That's weird. Okay. Huh. All right. Well, whatever. I'll take it. It's time to check out that keynote. Let's see. YouTube keynote. Was it build 2020? AI code. Let's see. Looks like this is it. You say it was around the 30th minute mark?
Welcome, and thank you all for joining today. I'm so excited to be here with everyone virtually this year for Build. I'm a maker and an engineer at heart, so this event has always been one of my favorite opportunities to connect with the folks out there doing the real innovation on top of the platforms and tools.
And we'll roll the video and show you what happened. I'm going to show what an OpenAI language model can do when applied to code generation. The model I'm using today was trained on code from thousands of open source GitHub repositories, using the same unsupervised techniques as our GPT models. Let's try it out. I'll start with a pretty basic Python task. I want to write a function to check whether or not a string is a palindrome. I'll start by writing the function signature and a quick comment string.
I've done this problem many times.
And now I'll ask the model to generate the code that it thinks should come next. Great, the model got it right. But that was a pretty simple example. If I searched for is palindrome on Stack Overflow, I'm sure I'd find something similar. So let's step it up a bit. This time, I'll write a function that definitely wasn't in the training set.
Long palindrome indices.
For elements that are palindromes. And at least 7 characters.
No way.
And let's see what code the model generates. Great,
all right.
that looks right. And you can use the is palindrome function from above.
Hey, yeah, that's super slick.
Didn't just copy some snippet from the training set. The model came up with a unique solution to a unique requirement. Let's step it up again. This time, I'll write an ordered class composed of items. I pasted in some code defining the item class and the properties of my ordered class. Now let's write some methods for the ordered class. Let's start by writing a method to compute the total price. But let's add a twist. Let's apply a discount to items that are palindromes.
The good old palindrome discount.
It helpfully writes a comment string for us.
It even wrote the comment. Nice.
But that's not quite right. I only wanted the discount applied to palindromes, not to the whole order.
Ah.
Let's edit the comment to clarify what I wanted. price and return it. Apply a discount to items whose names are found first.
Race car sale.
Let's try again. So far, so good. Great, that's much better.
That's insane.
Actually, I wanted the default discount to be 20% off, not 80% off, but that's an easy enough fix. There we go. Let's round it out by printing a receipt for the order.
Hey, no, I welcome our computer overlords.
Total price. And the
If you're listening, Alexa, I'm fine with you.
Here we go.
Wow.
Perfect. That's just what we wanted. And it even used the compute total price method that the model and I wrote together.
Yeah.
Helping implement functions, we've also seen the model excel at other development tasks,
Like
writing unit tests. All in all,
cucumber on crack. Or not crack.
Steroids.
Steroids.
Any developer more productive. Tooling built on these kinds of models will allow you to spend less time on repetitive, time-consuming coding tasks and focus more on the creative aspects of writing software.
Yeah, it's
Wow.
truly incredible what these models are capable of doing.
All right, that was super impressive. What do I got on here? Hey, it's us. All right, yeah, that was super cool. Thank you for sharing. That was awesome. I had not heard of that. I've heard a lot of stuff from Bill, but I didn't hear that. That was from 5 days ago, and I totally missed it. So thank you very much. That was awesome. Maybe I'll watch the rest of these while I'm cooking me some dinner. Wow, it's so weird to see him doing it from home. It's funny.
That can be used today.
That
Right
hat's
now
pretty
is your
awesome.
chance where you can go and help us shape the content of what you want to see at Microsoft Build. Why don't you take a moment and let us know what topics you'd like to see covered in more depth? Maybe something to do with
Is that a
cloud
biking
development,
shirt?
business application
All
development.
right, this is not the point, but Kuga shirt. It's a rugby shirt. Wow. Okay. All right. Well, that's interesting. Cool. All right. I'm gonna get out of here. Hope you all have a good one. Thanks for sticking around and knocking another problem out. We got a couple more days left in May. 4 more problems, so we're gonna do it. 2 months in a row.